This month's Data Science London meetup. So today we have another NewDay Data Science team joining us who will be talking about their continuous experimentation with chatbots. So please use the Q&A box to ask any questions throughout the webinar so the team and panelists can pick up those questions for you rather than using the general kind of event chat. I just want to also make you aware that we have the next meetup on the 17th of Feb, where we've got Robin Lester from Microsoft, who'll be talking about finding and removing bias from ML models with FairLearn in Azure. Also, if anybody wants to talk at any future Data Science London meetups, please just drop me an email at darshanashar262@gmail.com. Thank you. And I'll hand over to Donald from NewDay. Thank you.
Thanks, Darshana. Just going to share my screen. So, hi, I'm Donald Simi. I'm the head of data science at NewDay. We're very excited to share with you what we've been working on for the last 6 or 7 months at NewDay Data Science. We've been building an intent detection model, but we've built it in a slightly different way than we have built previous models. We realized early on that we had a lot of decisions to make as to where to focus our efforts in this model development. And we also had quite a slow model development cycle, a lot of labeling. So we realized that we wanted or needed a new way of being able to build and focus our efforts. And we found the framework and principles of Lean and found that this was a good fit for the challenges that we had. So we have adapted this Lean framework for enterprise data science, and that journey of doing those adaptations is what we're going to talk to you about this evening. So if I could just start by introducing the team. Alina.
Hi everyone, my name is Alina. I'm data engineer at the NewDay Data Science team.
Idelkis.
Yeah, hello everyone. I'm Idelkis. I'm cloud engineer in the data science team at NewDay, helping to build the platform like we use for our data task.
Josh.
Hi everyone, I'm Josh. I'm a data scientist here at NewDay, and I've been working as one since late 2019.
And finally, Peter.
Hi, I'm Peter. I'm a data science engineer at NewDay. I do mostly Python web development and bits of automation and DevOps.
Thanks, Peter. So NewDay is one of the leading consumer credit providers in the UK. We have 6 million customers. We have our own brand of cards, Aqua, Marbles, Opus, and Fluid, and co-branded cards with brands like Argos and Amazon, and many others. Our manifesto pledges to help people be better with credit, and you can see some of the numbers here on the screen that show how we're doing in that space. One of the numbers in the bottom right of the screen, one of the key ones for us in data science, is that we have nearly 3 million customer service conversations last year. So data science, machine learning are something that are really needed to be able to leverage this vast amount of conversational data. Before mentioning Lean or Lean data science or any of these new concepts, I thought it would be useful to start with a comparison to maybe how we traditionally used to build models. And maybe this is a workflow that will resonate with people. We would start with some data, do an EDA, define the problem. Then there would be an iterative predictive modeling piece, which would, we would choose our offline measures, maybe the area under the curve or the F1 score, and we would have an iterative process of trying to improve that. But it would always be offline. Our feedback that we would get would be internal to the company and not going to production straight away. So it's not validated learning from the customer with real feedback. It's iteration with internal proxies. And one of the challenges there is that it can lead to waste. You can build things that you think you're doing well, but actually when you release it, maybe you spend too much time building something that wasn't needed. So the framework of Lean is something that can help us in this situation. One of the challenges is that we do a lot of offline iteration and to get our models right, to make sure that we're going to be able to drive this change in the business, because it's not just a model. We're not just changing an individual black box model. We're changing how the company makes decisions. So that is that kind of process change is not that easy to realize. So Lean gives us a framework that we can actually try and solve this problem of switching from offline learning to online or validated learning. So for those of you who aren't aware, this is one of the, I guess, one of the most basic properties of the Lean framework, is that we have this build, measure, learn loop. So the key difference here from the offline iteration I mentioned in the previous or 2 slides ago is that this learning is validated learning. So we've shipped the product, we've shipped the model to the customer, and we're actually learning from them, from real feedback. And we get better at implementing this Lean principle by just minimizing the time that we go around this loop. So that's great. If Lean solves our problems, why can't we just use it straight away for everything? Well, it was formed in the environment of startups, where you're trying to find product market fit immediately, and you're not probably going to survive unless you do. You don't have the other challenge that we do in an existing established enterprise, is that you have, within an established enterprise, you have a reputation. You probably have, we're in financial services, so we're in a highly regulated industry. The cost of a mistake can be massive. You have an almost unbounded loss of reputational damage or anything from getting security wrong, data protection, not being able to audit our processes. These are all things that we need to ensure. Additionally, within data science, compared to maybe software development, that we have, it's getting better now, but we have a lack of mature production release processes. There's probably still some competing ways of releasing and production models. So it definitely doesn't have the maturity that we see in software development. So we've identified in this journey of building an intent detection model that we wanted to do through a Lean approach, that there were some barriers that we had to kind of get around. And so we've summarized them here in these 7 areas. So why are we building an intent detection model in the first place? I think if anybody is familiar with this area, they'll know that most of the major cloud providers provide an offering. We were already using Microsoft Lewis service at NewDay. So you want to have a good reason for kind of taking on one of those big tech companies. It's something that they see as strategically important. For us, that was adding an additional feature of actually being able to add our knowledge and context of the user into the learning model, as well as just the text. So that was the example here is I can't make a payment. What is the customer complaining about? Well, it might be that they're not able to actually make the payment on the application, or that their card has been declined and they're not able to purchase something online. If we use the information that we know about the customer that is non-text based and incorporate that, we could actually answer what seems a very difficult utterance to provide an intent for when just looking at text. So if we go back several months and we start with this initial build before we kind of stumbled on the Lean principles, we started with this intent detection model with a pretty well-known convolutional neural network architecture. We focused on the problem definition. We already had an incumbent model in Lewis. It had quite a lot of intents that the team was trying to predict. That team did not have data science or machine learning background, so they had just used the tool as they had seen fit, I guess. But so to increase the quality, we started doing a lot of labeling, and we realized that this was one of the huge roadblocks, and definitely a challenge for anything Lean, because the amount of time it takes to label this data. So you have one definition of the problem. We changed it from 36 intents down to 12, and then you have to relabel things. If you want to continuously adapt, as our business does, then you have to do a lot of labeling again and again, and it's just not very agile. As well as that, the other problem that we have is that actually intent detection is just one piece of the puzzle when we want to drive a better customer services experience. This is just a kind of an example of how intent detection plays into a broader conversational experience. We've got question answering for more FAQ type behavior, and then intent for things which have a matched business process. So really, for the customer experience, we want to optimize this whole system, not just an individual model. So lean processes are able to actually say, where should we focus next by running experiments? So we've identified 7 of these areas, and the first one is problem definition. This might seem a little bit strange when we talk about lean data science. Why are we talking about how we define the problem? Well, one of the challenges here is that this is a discipline, if you don't get it right, you could be several months into a data science engagement and realize that you've missed something crucial. Typically, our experience within this business is that, to understand a process holistically, to drive this order of magnitude change that we're looking for, that you really need to assemble a picture from several teams of what's happening to really improve it. So that means there's some challenges. We've got language barriers, different terminology. People are busy doing their own jobs, so they can give you some of their time, but not as much maybe as you'd like to really build a rigorous definition of your problem needed to do machine learning on it. So some of the tricks that we've used and have found useful that mean that we can get better at problem definition, which means we get it right earlier and we don't need to come back in a few months' time and fix where we've made mistakes, is not requesting sign-offs, which is something that is kind of a forced engagement. But we use some of the tools of the Agile framework, like demos, tests, and we also any changes to the definition of the problem are tracked through our source control system, which we need to put a pull request to. The last trick, which I'll expand upon because we haven't seen it done before, is actually to model the problem using probabilistic programming in our case, to say what we do is we look at our measures of success for the project in intent detection. One of the things that we're looking at is, can we keep people conversing with the bot rather than having to pass them off to an agent? And that KPI is called containment, which is important to us because it lets us know if the bot is actually, or if the customer is being understood by the bot. So we started this process trying to drive containment up by a certain percentage, but we didn't know exactly what that would be because we didn't understand the problem fully. Being able to model the problem using, in this case, PyMC3 and probabilistic programming, we're not using kind of the MCMC sampler here. It's probably something that we could have done analytically, but PyMC3 was just a tool that we already use, and so it was an easy way for us to be able to put a probabilistic framework to problem definition. So when we model the problem like this, we actually convert from a regular data science definition into a business prediction, which is how much can we likely increase containment by given the improvements in the model. So here I've actually converted the containments because that's the actual figures, but we'll talk about relative changes in containment. So Lewis was the existing model, Finn is the model that we've created, the intent detection model, and we've modeled offline in our probabilistic programming that we can increase containment by 8% knowing the parameters that we do. Why this is really useful for you is if you're able to make predictions like this that your business understands and have a financial implication, maybe that senior stakeholder is looking for a 15 or 20% increase. And now you're saying, well, we can only probably realize 5 to 8%. That may be because that's all the increase that you can actually realize, or it may be because you don't understand the problem fully. So it definitely gets a bit more engagement if that increase that you're looking for is not really going to be matched. So it's something that we found quite useful at getting engagement and converting from the language of data science into business early on. Another property that we look at is evaluation. We don't start any data science project unless we know how we're going to evaluate it. Typically, those measures are offline. Like I mentioned before, it could be mean absolute error, area under the curve, F1, and they're metrics of model performance. They don't really tell us what the model is going to do in the real world in front of a customer. So we need them and they have their place, but we also need to know that they're limited. And before we release, there are some things that we can do, which is actually practice mapping between these offline measures and our measures of success, our customer impact measures. So you need to define what your measures of success are for the project. I mentioned containment, which is keeping out somebody within the bot journey. We also look at things like time to resolution. So that would be a measure of success, which is very customer outcome focused. If we understand the relationship between things like time to resolution and improvements in bot performance historically, we can understand that before we release, before we ship, and it's like deliberate practice for getting to know the relationship between these model performance metrics and your online impact metrics. I think most of the time that we spent, and I think one of the areas that we've definitely figured out how to now do in a lean approach that we didn't know at the start, is within labeling. If you're building a supervised classification model, like something like multi-class intent detection, there's going to be a lot of labeling, certainly if you do traditional supervision approach. So we use AWS and we use SageMaker Ground Truth. It's been really beneficial for us, depending on what platform you're on. I would couldn't recommend using label management software. We started with Excel spreadsheets, which quickly became unmanageable. The label management software really helps you out here. We introduced 2 new kinds of label categories for our testing purposes. One was a golden utterance, which is deterministic. So if somebody wants to get something like a credit limit increase, they might say the simple statement, I would like a credit limit increase. That could be a golden utterance, which is deterministically should pass our testing. So the rest of the testing is kind of stochastic and non-deterministic, and we look at things like F1 score, etc. But really useful for us to just see that we're not making any mistakes by looking at something like what we call it a golden utterance or a small set of deterministic utterances. We are looking at a multi-class intent detection problem. Some of those classes are low frequency. So when we do a lot of labeling, we can still end up with a class which has tiny levels of support. So we can actually, we've a simple strategy is boosting these by having our SMEs create some seed utterances. Might be useful for you. The alternative is to just label more, but if they're really low frequency, that might take you a long time. Inter-rater reliability is something that we didn't start with, but have now found really invaluable. When we're looking at traditional supervision and trying to set a quality bar, we look at the IRR. It tells us how complex the problem is, and it also it can highlight any gaps in instruction, because when we review the results of the inter-rater analysis, we could see that maybe the reasons why people disagreed, and in some cases that can easily be fixed by just improving the instructions. So going back to the Fin model specifically, we developed this first CNN model, and then we realized we had a lot more intents to do in a sub-level, sub-intent model. And we're never going to get to finish this using traditional supervision with the amount of labels that we were needed. So at that point, we brought in weak supervision. We've used the Snorkel toolkit, which is great, and we couldn't recommend highly enough. But I guess it's important here in the context of Lean, because it's very adaptive. With weak supervision, we can write label functions. A label function, it could be as simple as if an utterance contains the word credit limit, then we should return true for the credit limit inquiry label. So it takes you a lot less initial development effort to use weak supervision. And we already have a lot of organizational knowledge within the business with our SMEs. So the lean labeling strategy that we've now ended up with is that weak supervision is our starting point for model development. So we start by writing label functions within Snorkel. We use traditional supervision with at least 3 annotators to ensure our quality bar. So, but then we only need to rate or to label a lot less for our QA assessment for our holdout set, the one that is labeled, say, 3 times by 3 different annotators. We need a lot less because it's not the actual training data, it's just the holdout test set. And the latest revision of that we've been doing, which kind of combines this benefit of training and QA and continuous improvement, sorry, is actual using our SMEs to do active learning, who keep improving the model. One of the challenges that we've had previously in building data science, building new data science models and bringing them to production can be platform infrastructure. If you're working in a cloud environment, it can be a slow development process for building and adding new services all the time. There's a lot to understand. There's a lot of permissions and that kind of complexity that you need to understand. And, you know, obviously there's concerns like security and data protection that I mentioned earlier. And this is really where we can build in those assurances that we're doing the right thing here. So the approach that we've taken is to de-risk the problem by removing personal data and PAN data or credit card numbers early. We use the Microsoft open source Presidio library for this purpose. We've had to adapt it slightly for UK names and addresses, but it works pretty well otherwise. I think AWS and Azure have other offerings in this space. Unless you really need to run a model on that personalized data or the card data, then you can change your the consequence of any data incident by just removing that early, and that's been really beneficial for us. We have different conversations with our security teams or with our data protection officer when we know that that data is safe. The other, I guess, innovation, I'm not sure if it is, but we haven't seen it done elsewhere, is that we separate into 2 development environments. The bottom development environment is an infrastructure development environment where people have the ability to change IAM roles, change and adapt services. We're using in SageMaker. It's quite, some parts of that framework are quite new. We're adapting them to work with existing services that we use already. So we need a good bit of trial and error to figure things out. So our infra dev environment is quite permissive in that sense, but we can't access real data in there. Our model dev environment is different because we do have real data in there. We can build actual tests that work on the behavior of the model, but we don't have the flexibility of being able to adapt IAM roles or to be able to egress any data out of that environment. So I guess the general advice is, you know, I would say don't just stick with existing environments that serve another purpose. Really think about your problem. Think, can we structure this differently to achieve the aim? And the aim is that we want to build quickly and safely and get to that validated learning as quickly as we can. One other useful tool in doing that is to focus on workflows. So this picture is of a DAG. I guess people might be familiar with them if they've used Airflow. Maybe they've used some of the libraries that I mentioned at the bottom here. MLflow and Metaflow have certainly been around for a while. But the advantage of writing your process as an executable, a single workflow like this, there's a bit of upfront cost in doing this. but it's much easier to take a process like this from research mode into production mode, because it builds understanding between data scientists and developers. You've kind of articulated what the process is. You can focus at the end pieces of this DAG and try and get them productionized, leaving the earlier pieces like pre-processing or training to be a bit more ad hoc, and then kind of build up this competence as you go. And by structuring it like this, you can see where the reuse is. I mentioned that we had several models to develop. We actually had 10 different sub-intent models. When you represent your problem like this within a workflow, you can easily pick out that we have the same, maybe one pre-processing step, which is used in all 10 of those model developed, and should be written only once and tested properly. Along with workflows, I guess this theme of we want to get better at switching from research mode into production mode. Software engineering is a big part of that. So we use what we've called, borrowed the term, I guess, progressive consolidation, which is that we start with notebooks, we start in research world, we start in exploratory coding, and then we move into more structured, more robust, Python modules that are tested, and eventually the notebook is kind of phased out. We work in Python, so apologies for anybody that's kind of not working within the Python ecosystem, because this slide mentions some tools that are libraries that are kind of useful there. NBQA is a library that was talked about recently at the ML EU conference. It is used to run things like autoflake, pylint, black on your notebook. Papermill is something that will run a notebook for you within a Python process. So now you can start to chain notebooks into a more orchestrated process. It means that we have all the benefits of notebooks, but we're able to place them into a kind of a more robust structure. And we definitely find that helps us go from research mode into production mode quicker with less waste. So the last of these kind of capabilities for areas that might prevent you doing lean data science is actually the delivery itself. I've just borrowed this image from an article on martinfowler.com about continuous delivery for machine learning. If you're not familiar with the practice of continuous delivery, I would suggest just reading that article. It's a great introduction to the topic, but mostly I think the most important part of that article is it's an introduction to the topic in the context of machine learning. Those practices, continuous delivery practices, is that we're integrating and producing the artifacts needed to release all the time, integrated with our source control and CI/CD server. So we've structured our problem as a workflow, and that workflow plays well with CI and CD. And now we're going to build this model as a process all the time when we're pushing commits to it. I haven't really mentioned too much about governance, but one useful thing, I think the Spotify engineering culture is also another thing that's worth a read, because they adopt lean principles and they speak a lot about how you should structure your team and how you should actually experiment safely. And they have the concept of limited blast radius. So if you're actually able to roll out to X percentage of customers and then let that increase over time, you can see if the model is doing well. There's two capability metrics that we're really looking to improve here. All of these properties that we've looked at, these 7 properties of kind of lean development, are leading us to improving in 2 key areas that we've called out, which is the mean time to MVP and the lead time to validated learning. It has taken us a number of months to get to this first MVP, and we've released and deployed this model in November, a couple of months ago. So, but it took us some time to build these things that we've talked about, to change the status quo of how NewDay works with software and production machine learning models. But we now feel that we can get that time right down on the next engagement that we have, which is key. And the lead time to validated learning is something that we've definitely now brought down a lot, which we would measure by the first time we do an offline experiment is when we have the idea, and when that has been released into production, and then we've learned from the customer how that has actually progressed in a live environment, then we have validated learning. All of the things that we've just mentioned about these improvements that you can make are really trying to drive those two things, because those two capabilities are how we can get the benefits of Lean within a data science workflow. Sorry, this last slide is just some of the things that we tried initially to try and automate everything in terms of testing, which didn't exactly work. The tests were too volatile. They kept breaking with false positives. So we actually just changed what we were aiming for there, and we brought in a kind of just a smoke test instead of a complete automated testing. And now we generate a HTML report that somebody can actually open. A data scientist typically opens within their Jupyter notebook. They navigate to the models that they're interested in, that they've changed, and then they look at characteristics of that model. Here we're looking at precision and the difference between the model they're about to release and the one that's in production. And that's been really helpful. So we don't need to do everything automatically, but we've worked it into the flow and produce some visual output that helps the data scientist make that decision to release or not. Okay. So I appreciate there's quite a lot in there. We looked at 7 areas that that were challenges to adapting Lean for data science. But I think if we've got the panel session, we can talk further into any of those areas. But I think that the key summary is that the Lean principles can help you answer a lot of the questions that you might have during a normal development process, but answer them in a way that gives you validated learning from the customer. Some of these data science specific adaptations that we've shown there can help you. And when you've done that, hopefully you can realize these benefits of this continuous intelligence cycle. I believe some of these references were shared in an email with the event. I'll leave them up here for a second so people can see. There's some references around Lean and Agile data science, and then maybe some people just wanted to come and have a research talk about chat and intent and all the things that were there. And I'm sorry if I've disappointed some of those people, but here's some of the things that we're reading in that area now, and excited now that we've built up this Lean framework to be able to improve the model by looking in some of these areas. Okay, so with that, I will switch over to the panel event and start seeing some of your questions. So, Peter, I think this one might be for you. So what are you doing around model serving?
Well, turns out that the team actually using our model is on a competing cloud provider. So we couldn't use any of the built-in AWS model serving. So what we ended up with is a fairly old school solution of having a Docker container, a Docker image, and we include all our trained models, which at the moment is one main model and like 11 kind of submodels. We bake them all into one image, and that Docker image is then our deliverable. And there's just a tiny Flask API on top of it all. And we started quite well because there's no dependency. So the receiving team, we just plug this in and it works without any other config. So the image is in theory like cross-cloud, but obviously we ended up with some Azure-specific instrumentation and stuff. But apart from that, was quite easy. I mean, there might be solutions to use some integration between AWS and Azure in this case, but we just went for the simple solution.
Okay. Active learning is part of one of the part of the labeling strategy. Alina, could you maybe tell us a bit more about how we're using active learning?
Yeah, we just started using active learning, and currently it's in the test. But the whole process is set up as self-serving. So this allows us to switch from manually maintaining our training set to fully automated one. And every time when we receive a new conversation data from Chatbot, this active learning loop kicks off a labeling job and retraining existing model. And so what we expect and what we see is that this current loop of relabeling and retraining model actually continuously pushes the model accuracy up. And also in our process, we started to engage in our customer services team with their knowledge is better, and we see the quality of labeling job is improved. And yes, basically the benefit is switching from manual job to fully automated. That's what actually the biggest benefit in active learning.
Yeah, I think this one would be for you, Josh. What kind of innovations are you looking at within the intent detection model itself? Things that haven't been implemented yet that you might be looking to do next?
Yeah, sure. So as you mentioned, Donald, in the talk, we sort of started out simple. So it's sort of a basic CNN where we've used sort of the first word embeddings that I guess you would think of, stuff like the word to vex and glove vectors. So we sort of realized quite early on that sort of using static word embeddings, resulted in, uplift in a lot of the metrics that we were looking for. So we really have sort of kept the architecture and the word embeddings fixed. But since we've sort of converted to this lean approach, and we sort of have a pipeline in place, something I'm looking forward to doing, and I've started a little bit over the Christmas break, is to look into the BERT vectors, which are sort of, the state of the art word embeddings at the moment. And yeah, so I think probably within the next coming months, I would say that we'd probably start focusing a bit more on the BERT vectors and possibly tinkering with the actual architecture of the CNN a bit more.
Thanks. Idelkis, in the platform space, so are there any kind of anything challenging when you're working on building new services, making sure they're secure, things like that?
Well, yes. Taking into account like all the machine learning and data services in AWS is quite new. Like for example, all the active learning and SageMaker pipeline, they were launched in the last AWS Summit end of 2020. Taking that into account, building something stable with the right permissions is quite challenging because you need to have the big picture of what you are going to do. And because this is a very dynamic environment, since the beginning, you don't know everything at once. So making sure like your IAM users and your roles, like you are assuming in AWS to do your task, have the right permission, but the least privilege is very important. And also trying to make all the stuff like you are creating in AWS in infrastructure as code, like trying to do that automatically, not manually, is also a big challenge nowadays, because normally we use tools like a Terraform, CloudFormation, or we build pipeline using Jenkins or something like that. And there are not too much in the community, in the DevOps community, about how to create those stuff automatically.
Okay, so there is a question here on how to make sure that the data in your model is bias free. I think I could probably pick that one up actually. So thanks, Hamad. At the moment, for intent detection or something like that, we look at protected variables, and we try and see that we're not using any protected variables. I mentioned that we use SageMaker. We're quite heavy users of SageMaker. So SageMaker have a service called, I think it's Clarify. It might be Clarity, which we can use for fairness and bias prevention. So right now, we have quite a simple approach of removing any protected variables, and that is what we need to do at the minimum. But where we would like to take that is actually using the Clarity or Clarify service from SageMaker to make sure that there is no bias in these models. So there's another question around automation tooling, which I think was not in the chat box. Peter, maybe we're looking at what tools we're using. And I know we mentioned SageMaker pipelines, but at the moment we're kind of using something a little bit more custom, which kind of involves some AWS services. Maybe you might want to expand a little bit on what we're using there at the moment.
Yeah, I think the question mentions notebook automation.
Yeah.
I think at the moment we don't directly have notebooks in our pipelines. I think notebooks are used to produce new input data, which is then picked up by AWS Lambda, and then SageMaker training jobs start and another evaluation job starts. So to answer the specific questions, we don't use notebooks directly. We use mostly Lambdas, which are triggered on received files. We also have a build server where you can manually retrain things. That's the kind of automation we have. Some of the Lambdas, they can get quite complex, or you can chain Lambdas together. I think part of the active learning, which Alina mentioned, we're using like step functions, which are basically graphs implemented in Lambdas.
Yep. I think, yeah, we have used Papermill, which is not a direct usage of a notebook, but wraps a notebook. And we've also started looking at moving to SageMaker pipelines. So if anybody is looking at how they can kind of implement CD4ML, SageMaker pipelines is something that really could achieve that, along with SageMaker projects. And they have also a service called Run Notebook, which is wrapping Papermill and is an open source project from Amazon. Okay, let's see if we've got anything else. So I wanted to maybe ask a question to anybody who feels like answering it about the interaction between, say, data scientist to developer, going from kind of research to production code, that process, and any tips, maybe not just kind of software tips, but how to manage that as a team. So I don't know if maybe Josh or anyone wants to pick that one up.
Yeah, I'm happy to. So when I came to NewDay, I was actually coming from academia, so I hadn't had much, if any, experience sort of taking a model all the way into production. So at first it was quite daunting, if I'm being honest, because there's a lot of things that I hadn't seen before. But what I found the most useful is just kind of like paired programming tasks, or sort of just one-on-ones with some of the devs, where I could share some of my data science knowledge, and they could share some of their development work. So I mean, it might sound sort of like a cliche, but I think just effective communication is really helpful there.
Okay. All right. So sorry. How far do you think chatbots can go with the right data? Is a question there from Hamad. I don't know. I'll have that as an open question. Whoever would like to on the team to answer that one.
I guess I could take that one as well. Yes, I mean, I guess with text, it's there's quite a lot of ambiguity. So in the talk we saw, what is it? I can't make a payment. And we have several intents that utterance could fall into. So something like 100% performance or what have you it doesn't seem possible. And what we've noticed is, we've amongst us, if we kind of have 3 of us do some labeling, the inter-rater reliability is, I forget, maybe is around like 85-90% for ones where all 3 of us agree on it. And the chatbot is already sort of at that mark. So I mean, if we had sort of millions of data points, maybe that could change. But I mean, I do think human text is a complicated object, but I think we've come quite far as sort of just a discipline with text.
Yeah, and I think one thing you could add to that is you probably will get to a point where it probably would just be better to pass that conversation off to an agent. So there probably will be this kind of law of diminishing returns once you hit, I don't know, 95% accuracy or something around that point. Okay, thanks for that, Josh. Somebody has a question around Kubeflow. So Kubeflow, we didn't actually use Kubeflow. We're not using Kubernetes within this. So we just rely on Docker containers and AWS services or Azure services like App Service. Kubeflow was just there as an example of a workflow. You could run your production workloads on Kubernetes using Kubeflow, which would give you a DAG and a workflow. So we have used SageMaker pipelines. We've used them within the SageMaker Studio environment. We're right now adapting or moving from this kind of Lambda and Bash-based custom system to SageMaker pipelines. They are mostly really good, and one of the challenges with SageMaker pipelines currently is that you have to wait for the EC2 instance to be provisioned. So you could run something that should take maybe a minute or 30 seconds to get feedback on, but if you've got 2 steps in this process, each one of those incurs an EC2 instance initialization time. So it'll take you 8 minutes instead of 30 seconds to get some feedback. So that development process is something we're working on because we want that cycle time to come down. There's a local mode in SageMaker pipeline, which seems pretty complex to get working right within SageMaker Studio itself. So yeah, we're not using Kubeflow. We don't use Kubernetes. We use Docker. Okay. Were there, I guess, any other challenges that maybe Adelkis, you probably joined the team a little bit later. And I believe this was your first role working within the data science team. So maybe were there any other kind of challenges of how people interact and get to know this workflow?
Yeah, sure. Yeah, this is my first role, building something for data mainly, because beforehand I was like a complete platform engineer. But in this case, understanding some elements of what is data science, how we do machine learning. Like I remember when we started building the ground truth and creating all those tasks for the labeling jobs and all the permissions and all things like we need to understand what is the result like we want to achieve. And I didn't have that knowledge when I joined, and where I'm still getting there. But yeah, bit by bit, understanding how the team works and what is needed for them, still been a challenge. And as I said before, all those services are being quite new, or they are always launching stuff, or they are building new services. Like we know how to use it, but sometimes the tools like we use to deploy, they are not sync with what it is in the UI, in the AWS UI. And I'm talking about AWS because this is what we are using. So getting up to date with what is happening in the machine learning world is still a challenge, I think, worldwide.
Okay. Just think that I've answered everybody's questions at this point. All right. Well, thank you very much, everyone. I hope people enjoyed that. Yes, thanks very much for listening in, and for us to be able to share this, I guess, the start of this journey of being able to develop models according to this Lean framework. All right. Thanks, everyone.
Yeah. Thank you.